Dale, Mrs. Arndt here. This is your Core Math 2 Week 3 Lesson 1, and it is all about right triangle proportions. So one of the items that we're going to take a look at today involves, an activity we would have done in class with some right triangles. So as you can see here, what I have are two identical right triangles. These are congruent in every way. Their lengths are the same, their angles are all the same, and they have drawn an altitude going from that right angle at the top down, meeting up perpendicularly with the base along the bottom. So what I'm going to do with these identical triangles is I'm actually going to cut one of them along that altitude. So again, it's still part of the exact same triangle, but now it has been cut and it has made two additional right triangles. And so what's interesting about this is if we do a little bit of turning upside down perhaps, what we can do is we can lay out along the original right triangle two additional right triangles made up of it, and these are all similar right triangles. They are in perfect proportion with one another, where you have your short leg and short leg, you have your long leg, long leg, long leg, and then you have your hypotenuse lengths. All three of these right triangles, the original and the two that it was cut into, make up proportional right triangles. So what does this mean for us when we run into some mathematical examples? Well, when we're dealing with some right triangle proportions, if we start with one right triangle and it gets cut by an altitude, we can set up ratios that are equal to each other based on short leg, long leg, and hypotenuse. So here in example 1, it wants us to find the length of h. Well, if we look at the triangle on the left side of this situation, 8 appears to be the short leg, and h appears to be the long leg. Meanwhile, the unmarked length is the hypotenuse. So this word hypotenuse, it's always across from the right angle, and it's always the longest leg in the triangle. Here on this triangle on the right half, well now h is actually the short leg, and 22 is the long leg, and the hypotenuse is unmarked. It's the one across from that right angle. So if I go to set this up, I would set up a ratio about the short leg over the long leg, because we have those same two lengths in both of these triangles. So for the triangle on the left half, the short leg is 8 and the long leg is h. But for the triangle on the right, when we set this equal, the short leg to go on top is now h, and the long leg is 22. So when we look at this, it becomes kind of a unique proportion, a unique situation. We would normally just cross multiply and divide, but we're actually missing two parts. However, they're the exact same variable. H times h is h squared, and this is equal to 8 times 22. The cross products are equal to each other. So if we grab a calculator and we take 8 times 22, it's 176. So h squared is equal to 176. And to solve, we would apply a square root to 176. And if we're allowed, we can say h is 13.3 approximately to the nearest tenth. But if we have to write it in simplest radical form, we would try to break down 176 into a perfect square that divides out of it evenly. 36 did not divide out evenly, neither did 49, neither did 64. So let's try maybe something smaller. Oops, 176 divided by 16 is 11. So we could break that down into the square root of 16 times the square root of 11, which is 4 times the square root of 11, or like I said, 13.3 if we can write it to the nearest tenth. Okay, so let's take a look at maybe another type of problem that you might run into. And here in example 2, we have a slightly different setup, and they want us to find the length of x. Well, x is going all the way across. It's part of the original triangle, the big triangle. So if we're looking at the big picture here, x is the hypotenuse because it's across from that right angle. Meanwhile, 12 is the short leg of that triangle. So we have hypotenuse and we have short leg. So now let's see what we have in the triangle on the left. 12 is across from our right angle. That's our hypotenuse. And 4 is the length of the short leg. So we have the exact same lengths from each of these two triangles. Now for the triangle on the right, we don't have any information about that. So we can ignore that one. We only need to focus on two triangles at a time. So if we're looking at that big triangle and we put the hypotenuse x over the short leg 12, that would be equal to, looking at the next triangle, the hypotenuse on top, that's our 12, over the short leg 4. So this one is a normal proportion where we have one unknown piece. So we go to the two we know, 12 times 12, and we can divide by 4 to find out what x is. So 12 times 12 is 144. Divide by 4. Grab a calculator or your Delta Math calculator. And so x is 36. That's the length of that hypotenuse. So head on over to Delta Math and do a little bit of practice on these right triangle proportions.